we're going to have a run through how to set up and figure out tilt angles, shading and spacings between rows. Now this is very important when you're starting to do any kind of design work where you are going to put tilt frames onto a roof, or where you're doing multiple rows of, say, a ground mount system. This all operates on the same principle. So the first thing we need to work out is what our winter sun angle is. So it should be a picture pop up on the recording. Basically, we're looking at if our winter equinox angle, our little sunshine, is going to be our latitude, 90 degrees minus our latitude. So that's our equinox. So for where we are currently, or where we're going to base this out of, is where I currently am. So we are at near enough 37 degrees. Sorry, that's not our 37, that's 37. So at 60, it's 53, so 53 degrees is our equinox. Now, to get to our winter solstice, because it's lower in the sky, is going to have a reduction in angle between there and there of 23.5 degrees. Let's see if my maths are any good here, which should give us a winter sun angle of 20, so 50, it's 30, so it's 29.5 degrees. Okay, if I've done my maths right, that should be correct. So it's near enough, and we can just round that up and say 30 degrees. So now what we've got to look at is the setup of how we would actually set some panels up. I'll leave that up there for now. Okay, let's set some panels up. So we're going to have let's say we've got our sun over here. We're going to have our first panel there, which will have a frame. Generally we're using our tripods or some kind of similar setup. Then there is going to be from the sun, there's going to be this reverse angle, which will create from that same height all the way through this reverse angle. And that will tell us where that shadow will hit. We're going to plus 100 millimeters there, and then we can put our second panel with its tripod under it. So what we need to know is from this constant point of the back edge of that triangle frame to the back edge of that triangle frame, we need to know what that distance is, because that's going to tell us what all of our spacings are going to be. So we start this with what we do know. So let's fill in what parameters we know. We're going back to Pythagoras' theorem on triangles when we get into this. So we are looking at the panel that we're going to use. Very important. That's our physical size. So our panel overall length is going to give us our hypotenuse, which is 1762. So we know this one here, 1762. Now we don't need to worry about how far off the roof or anything it is, because by using the same mounting system each time, we're going to have this, the same spacing off the roof on either. So we just pick a definite set point, which is going to be the front edge of the panel, or in this case, back edge of the frame, back edge of the frame. They're still all consistent. Anyway, let's run this one. And so we know what pitch that we're going to put these at as well. So we're going to put this at 30 degrees. It's pretty standard for the southern part of Australia. We want to pitch at 30 degrees to pick up that winter sun. Okay, that is going to now give us, on this, we know our hypotenuse and we know our angle. The quickest way to do this, if I can wake the laptop up, is you just jump online and grab a right angle triangle calculator. And so it will let us fill in, what's our A angle is 30. It's going to give us, let's get rid of that. Our hypotenuse was 1762. You only need to have one length and one angle, and it will give you everything else because a right angle triangle works on fixed parameters. We know what that other degree measurement is. So that tells us now that A, which is our rear height, is 881. So that is this height from here to here. That there is 881. Okay, that's the only other height we need in this figuring out. The rest of this is irrelevant. So now that we've got that height, and we know our sun angle, whatever we calculated that at, is this 30 degrees, it means we also know that this, in its reverse, is 30 degrees. That's that same angle that we're looking at, that shadow. So this is midday in the middle of winter. So now, let's recalculate this. We've got the same well, actually it's going to come out the same. I'm just looking there going, hang on, this is going to come out the same. If that number was different, this would all change. But anyway, because this is 30 degrees, that's 881. We're going to be at 1762 as our reverse angle, just because of that, because both angles are 30 degrees. If this location was different, and that number is anything other than the same 30 degree of our pitch, then this calculation would change. So let's just go through it. So now we would go, the height there is 881, 30 degree pitch, we're going to calculate that, and it is going to give me that my C there, 1762. It also proves our calculation was right. So that means that one there, 1762, actually we did need to write one other calculation in, one other measurement in there, B, which is 1525. Thankfully it's the same for both. 1526. We round up. So 1526, 1526. Now again, if it wasn't 30 degrees, those numbers would be different. So that gives us our length to this center point, and then our length again back here. So now we're going to add up our two bottom lengths, now that we know what that is. So let me do that. Just to make sure my calculations are accurate, I will type it in, 1526. So that is going to give us 3 meters and 52, so 3052. So from the front edge to the front edge, sorry, not that, front edge to back edge, there, let's just take those down. But that there is 3052. Then we're going to put our 100 in there, and that's where we're going to start our next one. So our spacing on this is 3152. Now that we've got this 100 mil of play we're putting in here, this is just to make sure we're definitely clear of any shading and any kind of issues in the roof spacing or roofing material. So 2 mil, and just to make it easier for all your rooftop calculations, I would just make that 50. So that actually becomes 98. 3150 as a spacing is from any fixed point. So that's going to work if you calculate it from front edge of panel to front edge of panel. It will work if you go back edge of frame to back edge of frame. As long as you use the same spacing, you now know that this is going to give you clear sunshine at the winter solstice for this location. And then anything in summer, or anything that's not winter, anything better sun angle than that, because the sun comes up from its lowest point, comes up higher in the sky, you're going to have less shading issues. So this guarantees we've got no shading issues for winter. Now the other thing you'll maybe thinking, well, at lunchtime the sun is at its highest point and it fades lower left and right during the day. Yes, but what you have, so let's say we've got a row of panels, terrible drawing I know, but bear with me. When the sun is shining in here, it's going to hit these panels and it's going to cast that reverse angle. And so that now creates this shading through here. As the sun, early in the morning, midday, late in the afternoon, this angle from the sun to the top edge of the panel over to the next sets of panels actually gets longer as the sun gets lower. Of course, if the sun's lower, we need more angle. We get that because rather than being straight on, we're now around to the side. So rather than having that distance, between the two rows, you've actually got this distance. So as the sun drops down, it actually goes round to the edge of the array, and for the most part, you won't get any other form of shading on there. So working it out off the midday sun actually works for that reason. So hopefully that's clear enough. If you're needing to work out your spacing, this is what you do. Remember, you're going to need to know what your pitch angle is on the frames, on your panels. You're going to need to know the overall length of the panels, and then you can calculate everything else. You're also going to need to work out your winter solstice angle before you start, but that's it. And then you can just plug that in, and that is going to give you how to work out all your array spacings.